guys, now we're going to look at adding two numbers that have opposite signs. So looking right here, I have a positive being added to a negative. Positive 6 plus negative 4. We're going to see what the rule is. It's different than when we were adding two positives or two negatives. Then we just added the number and kept the sign. This is going to look a little bit different. Let's start by looking at the chip model. I have a positive 6, so I'm going to make 6 black dots. 1, 2, 3, 4, 5, 6. That represents my positive 6. And then I'm going to need red for negative 4. And I'm going to make 4 red dots. 1, 2, 3, 4. Now I'm looking for 0 pairs. A red and a black that cancel each other out. So right here, there's 1, there's 2, there's 3, there's 4. So those canceled out to 0 because any positive 1 plus negative 1 is 0. We are left over with 2 black dots, which means that our sum is 2. I'm also going to look at this on the number line really quick. So always start at 0, and I'm going to go up to the right 6. 1, 2, 3, 4, 5, 6. Now I have to move back to the left because I have a negative number. And whenever you're adding a negative number, you move to the left. I have to move to the left 4 units. 1, 2, 3, 4, which leaves me again at positive 2. Okay. So what's happening here is we're taking away 4 of the positives with those negatives. So this is the same thing as positive 6, but I've taken away 4 of them. So really what I'm doing here is subtraction. I'm left with a positive number because I had more positive than I had negative. So I'm taking basically the absolute value. So that means let's just pretend both numbers are positive and I subtract them. 6 minus 4 is 2. I know it's going to be positive because this had more chips or had the longer line on the number line. So you take the absolute value of both numbers. So basically, absolute value of 6 minus the absolute value of negative 4. The absolute value of negative 4, that's saying how far is it from 0 on the number line. We're just making it positive, equals 2. And then I say, which number is further from 0 on the number line? That one's 6 units from 0. That one's 4 units from 0. That's going to be the one that has more chips left over, the one that has a longer arrow. That's going to be the sign of my final answer. So that's one example. Another example is negative 5 plus 2. So negative 5, that means I'm going to make 1, 2, 3, 4, 5 red chips. And I'm adding to that 2 black chips for positive 2. I'm looking to cancel out my 0 pairs. This negative 1 and positive 1 cancel each other out. This negative 1 and positive 1 cancel each other out. I'm left with 1, 2, 3 negative chips. So my answer is negative 3. If we were to look at this one on a number line, I would, as always, start at 0. I'm going to move to the left because that's a negative, 5 units. 1, 2, 3, 4, 5. And of course, I end up at negative 5. Then I have a positive number, so I'm going to move 2 to the right. 1, 2. And that leaves me at negative 3. And again, looking at this, as you get used to it, you see that the negative number has a greater absolute value than this. It's like it's a bigger number. So I know I'm going to be left over with some red chips, or that this arrow is going to go further in a negative direction than this one is in a positive direction. So if I didn't want to use a chip model and I didn't want to use a number line, I could just use the algorithm, subtract the absolute values. I'm ignoring the signs. I'm taking the absolute values. The absolute value of -5 is 5. The absolute value of 2 is 2. Just making them positive. I'm subtracting them, and I get 3. But then I have to look at it, and I have to say, which one had the greater absolute value? Which one's farther from 0? Because that one's going to be the one that my sign is. This is further 5 units away from 0. This is 2 units away from 0. I know that my answer is going to be negative because it's this one. So then I just put in a -3. So you're taking the absolute values of the numbers and subtracting them, and then looking at which one had the greater absolute value, and you're keeping the sign of that one. There's going to be more negative than there is positive. I'm going to do one more. We got -3 plus 5. So I'm going to do 3 red dots for my -3. And I'm going to do, oops, there it goes, 5 black dots. And then I'm going to cancel out my 0 pairs. Cancel this, cancel this, cancel this. I'm left with 2 positive chips. That's +2. I'm going to double check my work on the number line. So I start at 0. I go left 3 units to -3. And then right from there 5 units because it's positive to the right. 1, 2, 3, 4, 5. So this arrow went back into the positive zone because it's longer than this arrow. We went 3 units to the left, but then we went 5 units to the right, which brought us back into the positive zone at +2. So that much got canceled out. Those 3 got canceled out. So if I think about it using the algorithm, I take the absolute value of both numbers. The absolute value of -3 is 3. The absolute value of 5 is 5, and I subtract the numbers. Take the bigger one, subtract the smaller one, and I get 2. And then I look back at my numbers. Which one of these has a greater absolute value? Which one has the longer arrow? Which one is further from 0? This one. And it's positive, so my answer has to be positive. Thanks, guys.